So, as already introduced, I'm Herbert Banda from the African Center of Excellence in Innovative Teaching and Learning of Science and Mathematics, University of Rwanda, College of Education. Currently in Malawi, working at the Physics Department at the Lilongwe University of Agriculture and Natural Resources, and as well as a part-time lecturer. So we are specifically looking at this topic of enhancing students' conceptual understanding in physics. So it's a synopsis of the phase 1 studies which were done over the past decade to see how PhET simulation enhances conceptual understanding in physics. So the presentation would follow this outline. We have the title slides, the introduction, the results, the discussion, then the conclusion. So on the introduction, we will look at the conceptual understanding. So the study defined conceptual understanding as a functional understanding of the logical ability to apply knowledge in contexts or scenarios other than the one it was generated or attained. Other scholars also defined conceptual understanding as the student's ability to reason in settings or environment that require careful application of concepts, description, relationships, or representation. Thus, all in all, conceptual understanding demands students' ability to synthesize information and knowledge from known schemas and apply it in new contexts or scenarios. So, as educators, why do we need to develop conceptual understanding among our learners? The following are the reasons which we noted from the studies or the literature review which we did. We noted that it is important to develop conceptual understanding among our learners just because it helps them to connect knowledge across physics concepts, physics context, so that facts and procedures are not isolated. So they usually do this connection of facts and procedures through the use of concepts maps, mind maps, reflections, and other methods. Another reason why we need to develop conceptual understanding among our learners is it is essential in the metacognition in the students. Metacognition is defined as memory monitoring, and so if we are to develop metacognition in our students, usually we are enhancing higher order thinking, which involve active control of the thinking processes involved in learning, as well as metacognition helps students to relate facts to the overall frameworks, apply facts to the frameworks, and testing frameworks against the facts. So it's a whole lot of synthesizing the information so that they should develop the conceptual change which is needed. Furthermore, it is also vital in helping students to transfer knowledge to new situations. So this helps the students to test the theories which they have learned in classes. At the same time, it also sparks innovation. So it gives a room for innovation among our learners. So all this is pointing us to the demands of teaching in the 21st century. So the demands of teaching in the 21st century is centered on teachers being creative and original in using their available resources. Fully, we are living in the 21st century where ICT is in the forefront. So as teachers, we have to be creative as well as original in using the available resources to the maximum. For instance, the use of PhET simulations and other animations or simulations which are out there, which can enhance learning. Furthermore, teachers need to be agile and they have to adapt to the environment. Curiosity and imagination is also another demand for teachers in this era. Critical thinking and problem solving, collaborative learning, technological skills, and digital literacy, they are the demands which teachers need. So all these demands, they are just pointing that teachers need to enhance the integration of ICT in the learning situations. So 21st century is demanding so much more from teachers so that learning should be achieved with learning should be achieved by getting the best objectives for our learners. Then we go to the research section. On the research section, we are going to look at to what extent do PhET simulations enhance conceptual understanding. So the literature review which we did reviewed the following. PhET simulations helped in developing skills in making scientific predictions, as well as explaining the given phenomena with more valid scientific ideas. It also helps students to elicit pre-existing understanding, and it also gives them the opportunity to challenge their initial understanding. So this enhances conceptual change as well as conceptual understanding. Furthermore, it also improved students' cognitive skills on the use of factual and procedural knowledge, transfer knowledge, applying knowledge to relevant tasks. PhET also helped students to develop inquiry and exploration skills in the students. It also removed misconceptions in the students. So when the students were interacting with the PhET simulation, they had their prior conception of the phenomena, but upon interacting with it, it led to the development of the right conceptions. The misconceptions were removed. It also helped in outlining theoretical concepts and giving constructive feedback. So the feedback was constructive, and it helped them to develop the right conception of the physics phenomena which they were learning. PhET also helped to develop the correct scientific explanations and the feedback and immediate feedback. So interacting with PhET simulations helped the students to develop the right scientific explanations, as well due to the recursive feedback feature which PhET has. It also helped the students to develop critical thinking, as well as the thinking which is needed in science. PhET also helped in outlining physics concepts without relying much on the use of mathematical operators. It improved physics, it improved their thinking skills, concept analysis, creativity, innovation, and many others. Lastly, the use of PhET simulations. PhET simulations help the students to develop this ability to transfer and apply concepts and knowledge to new learning. So all these are the extent to which PhET simulations enhances students' conceptual understanding of physics. So from here, let's go and look at to what best ways was PhET being used in the classroom. So the literature review also helped us to identify the best ways in which PhET simulations were being used to enhance conceptual understanding of physics. So we identified 4 best ways in which all the papers highlighted as the best ways in which PhET simulations is to be used to enhance the understanding of physics. The first one was inquiry learning. So inquiry learning was identified if it had the following elements. Inquiry learning, the first element was elicitation and clarification. So on elicitation and clarification, it involved students having discussions, eliciting their prior knowledge, as well as trying to identify misconceptions which they had. So on elicitation and clarification, students were involved in group discussions where they were trying to elicit misconceptions which they had on the phenomena or the concept at hand, as well as trying to understand or bring their prior knowledge to the learning. Then after the elicitation and clarification, the students were given a room to make predictions. So they deduced the hypothesis from the discussions which they did earlier. So they were making predictions as well as clarifying the students' prior knowledge here. So they made the hypothesis. After the hypothesis were made, they had to clarify their prior conception. So the third stage was to test the prediction which they made. So upon making the hypothesis, the students were given a room where they can test their hypothesis. So they were testing the hypothesis in PhET simulation. So they were given they were in the computer laboratories where they were doing their testing of the hypothesis. Then the fourth stage was elucidation and linking. On elucidation and linking, what the students were doing was they were linking their findings to the hypothesis. So the students here, they had to back their findings with scientific reasoning. So they, after testing the hypothesis and gathering the data, the students were given a room where they could discuss their findings. This discussion was in form of the class presentation or else the teacher-student presentation. The teacher-student presentation was in form of the teacher consolidating the learning. After this stage, the students were asked to do further testing. So on further testing, the students were asked to go to the library or use the same PhET simulations to test their idea. So they were given a room to further test their thinking in order to further develop the conceptual understanding which was needed on the physics phenomena which they were discussing. Then the second method which was identified to be the best one was problem-based learning. In problem-based learning, was identified if it has the following elements. So in all the studies which we reviewed, it was noted that the first step for problem-based learning was to assign a problem to the students prior to learning. So you give a problem to the students to research on it so that they should gather more knowledge on it. Then the second stage was to evaluate and synthesize the knowledge. So once they have gathered the knowledge on the problem at hand, they were requested to further evaluate and synthesize it. So upon synthesizing it, the students were asked to form a hypothesis as well as design an experiment. So the students were given a task to create or to deduce their hypothesis, which was followed by them designing an experiment which they were to conduct on PhET sims. So after designing the experiment, the students were asked to go to the computer labs where the computers were with the PhET simulation. So they would open their PhET simulations and test the hypothesis. This was followed by collecting, interpreting, and making conclusions on the data. So after experimenting their hypothesis, the students were tasked to collect, interpret, and make conclusions on the data. Usually the teacher was also in charge of verifying or helping the students to come up with the right design for the experiment which they were to conduct. So they will go to the labs, experiment, then collect the data. The teacher will also come at the end to consolidate the learning, that is to make the learning to be in line with the expected objectives. The other best way which was identified, the other best way which PhET was being used to enhance conceptual understanding was virtual lab experimentations. So studies also reviewed that PhET simulations can be used as virtual laboratories to enhance conceptual understanding. It was identified that virtual laboratories were being used, virtual laboratories which were being used in form of PhET had the following elements. So the elements of virtual laboratory as follows: the presence of a lab manual or protocol. So the instructor or the teacher had to design a lab manual or a lab protocol which was to be used in teaching and learning. So the teacher had to design the lab manual protocol or the experiment which was to be conducted. Then the lab manual had to have tasks and procedures which students have to follow. So the procedures were in line with the manipulations which happen in PhET simulations. Then the students were asked to go and collect data in PhET sims. So all this is happening in PhET sims. So you design a lab manual with tasks and procedures, ask the students to go to, ask the students to go to the computer lab where the experimentations or experiments will be done. They have to collect data. Once they collect data, for instance, if they are collecting data on, let's say, an experiment on young modulars, they should also have Excel with them where they will analyze the data. So they will draw their graph maybe on Excel. Once they have drawn the graph on Excel, they have to interpret the data and discuss the results. That is, they will discuss features, for instance, like what shape of graph is being produced by the data which they have collected in PhET sim. What is the value of maybe the gradient which they have, what is the gradient of the graph which they have plotted on in Excel, and relate it maybe to the theoretical value of the gradient which is in the literature. So that was on virtual laboratory experimentation. Then the other one was on scaffolding learning. So on scaffolding learning, what was happening was it involves helping learners to fill the crucial gaps in learning ability. So the teacher identifies the areas which are crucial for the teaching and learning process to happen. So the teacher will help the students in filling the crucial gaps in knowledge and ability. The teacher also is involved in supporting the students to complete the task. This is with minimum help. So you put the student in front, but with your guidance, they are able to achieve the required objective. So the teacher has the task of adjusting the amount of help which is given to the learner in order to not overshadow the level, the highest level which a student can go to attain the required information or knowledge. Usually in scaffolding learning, they use the term which they call expert modeling. So on expert modeling, the teacher helped the students to discuss aspects of the problem which they consider to be very crucial so that the problem should be solved. Then later, the teacher and the student had to design animations and visual experiment which the student had to go and experiment so that they should collect the required data. Hence, they collect conceptual understanding. Lastly, the students were given a task of drawing concept maps that the students were given the task of developing a concept map that outlined the crucial elements which they have learned. So these are the 4 best ways which we identified from the literature review, which we did as the best ways in which PhET could be used. So we had the scaffolding learning, then virtual laboratory experiment, inquiry learning, as well as problem-based learning. So all these teaching methods or active learning methods, if implemented in the classroom, they enhanced the conceptual understanding of physics. And the results which the researchers found, they noted that indeed the students were able to gain the right conception of physics. So if we are to enhance conceptual understanding in physics, we can try to apply these concepts or these active teaching methods in our classroom, and the outcome will overwhelm us. Then let's look at this part where we are looking at what is important for the African context and as educators. So here we are looking at what can benefit us in the African context, as well as what can help or benefit educators. This is what we gathered from the studies which we reviewed. It was noted that schools owning computer laboratories should be equipped with skills in integrating PhET simulations in the teaching and learning to enhance conceptual understanding. It was also noted that teachers in Africa be exposed to a sea of free education resources like PhET simulations to maximize learning experiences. So there are many computer simulations out there which, when used in the teaching and learning, the learning experience is maximized. So one of them is PhET. So it is very vital if we can, we as educators are exposed to many of them, so that at least we should combine. So if we can combine this, the outcome of the teaching will be very huge. It was also noted that it would be good if efforts are put up in place to train teachers on how to integrate PhET simulations and other simulations into active learning designs for students to attain conceptual understanding. So the literature review which we did also identified this as one of the key points which has to be addressed, which is to put in place or to train teachers on how they can integrate PhET simulations and other simulations in active learning design. So the active learning designs which we noted as of now are the ones which we have discussed before. Lastly, the literature review which we did also called on educators in Africa to explore PhET simulations which have been contextualized for their local languages. So if we can explore PhET simulations which have been contextualized for our local languages like mine, Tijewa, we can try to ease how we clarify abstract concepts. So in our local languages, there are PhET simulations which are in Tijewa. If we can use them to teach physics in our classes, it will be easy for the students to gain the understanding. Hence, conceptual understanding is to be achieved, since the barrier in language will be reduced. Then, as educators, it has also been noted that teachers should embrace and spearhead the integration of PhET simulations in our teaching and learning of physics. So it is a plea to us educators to be in the forefront of spearheading the integration of PhET simulations in our teaching and learning. We can use them in the ways which we have discussed. We can use them as virtual laboratories. We can use them in inquiry learning. We can use them in problem-based learning, as well as scaffolding learning. So if we are at the forefront of spearheading this, we are going to have a huge impact in our teaching and learning. So our students who experience the diversity which is needed, we should change how we teach in a way that the students should see a variety, and they should always be happy to be in our classes. As well as educators should embrace networking and enhance collaborative working to share the best teaching practices and resources. So us as the educators, we should embrace networking, at the same time be able to work with our colleagues so that we should acquire the best teaching practices and resources. So there are the resources which we are talking of PhET sims, as well as many other open access education resources which we can integrate in our teaching, as well as us educators should explore and align PhET simulations to physics topics and objectives which are in our syllabus. So we should take time to align the objectives which are in our syllabus with PhET simulations. This is going to give us an easy resource which can be used in the classroom. So PhET simulations, researchers, they have said that they are powerful interactive visualizations, as well as there are animations which, if we can use them, we are going to enhance our teaching. So let's maximize the learning in our classroom by aligning the PhET simulations with the objectives in our syllabus. This is the last part of our presentation, and it is making me to stop here. I would love to call questions from you, our audience, so that we try to clarify points which are not clear, as well as I get to interact with you. So I would like to thank you for being a good audience. Thank you. It's time for questions. Please, let's bring them in.
Awesome. Thank you so much, Herbert. There's so much there's so much punchlines and things to further drill into, but I'll save that for later. Please, if you have questions, this is a good time to use the question and answer feature. Please write in the question and answer feature questions or clarifications or even contributions you might have, and the speaker will be happy to address them. If you would also like to speak directly as against typing, please raise your virtual hand, and we'll be happy to pass the mic so that you can ask your question directly. Thank you so much, Herbert, again for your presentation, like from the active learning strategies that were proposed to the need for the teacher capacity development to become comfortable and confident around the use and integration of PhET and related tools. And it does not end. They also mentioned the need for teacher action. Teachers would also have to become ingenious or find ways to align, of course, the scene to their objectives to take advantage of the powerful visualization and interactions that it provides. Like you mentioned, in this age and time, students are more, we live in a world now that, of course, learning and teaching now is not as it was in the past, perhaps when education was designed where the learning of facts and procedures was just enough. With the internet now and technology as it is, like all of this is available, and learning of facts is not enough, and being able to situate or apply this concept in different contexts is important, and that starts with us as educators. Thank you for this extensive research as well. I don't know, do we have questions at any point? Questions around perhaps the procedures? There were inquiry-based learning to problem-based learning to scaffolding, and then experimentation with the visuals of the scene to be able to drive student conceptual understanding. I don't know, do we have questions or clarifications around that? Would love to hear from you, our audience. Any questions or contributions? Okay, so while we wait for questions or contributions, perhaps I'll just look through the chat again in a minute. I see, thank you for joining, Johnson Rutera from Rwanda. Thanks for the presentation. So everyone is saying thanks. So she said, thanks for your presentation. If you have a question, okay, yes, we'll come to, if you have a question, please write in the chat and we'll get to it. Herbert, I would also love to know, so you did recommend or advise teachers to take action around these things. Do you have thoughts or recommendations around obstacles, or what are barriers to teachers' adoption and use of this tool? Like, the tool is available, the methods have been explained, and you provided steps as well that are very easy to follow. But from your experience, the teachers have reservations or barriers or challenges that you think it will be helpful for other teachers to be aware of so that they can navigate or find their way around effectively using this tool to help develop conceptual understanding?
Okay, my view on that one is this one, which I made when I was doing another research on PhET. Teachers in the schools which I interacted with, they were not confident in using the PhET sim. That is, we need more like a paradigm shift, paradigm shift in a way that we should now maybe put the teaching of physics or another subject in secondary using this computer simulation. So what needs to be done now is like more training has to start maybe from college where they get their training, or else the in-service trainings, they are the ones which can help to boost teachers' confidence on the use of this PhET. Usually, if you are just to walk through them on how they are to use these PhET simulations, many of them, they are not confident, but they would say, okay, you'll be the one who will be operating on the sims or giving the instructions. That just shows that they are not confident on how they can use it, but they are open on using it. So it's just all about this resistance which is there. Once you teach them how they are going to use it, they'll use it while we are there, but later they end up like leaving it just because they have some reservations, as in they are not confident on it. So that's one point which I noted when I was interacting with teachers on how they are to integrate these PhET simulations in their classroom.
Awesome, thank you. It's important to develop teacher confidence around the use of the tool, and confidence actually comes from repeated use. It's not from keeping a distance and just, of course, having different ideas around it. It comes from actually trying and putting it to use in your classroom. Thank you. I think that answers your question, Samuel. If you think that doesn't, please write again, and I'll just push that forward again. And we have a question from Utasi Mwaba. I hope I pronounced that right. Apologies if I didn't. Please, any comment on students' attitude towards the use of PhET? That's a bit different from like the scope, but I don't know if you would like to speak to that. And how was the performance? How was the performance based on the studies reviewed? Like what was the method? I think, yeah, what was the method you adopted in conducting this research? And do you have what are your thoughts around students' attitude towards the use of PhET sims?
Okay, the attitudes of students towards the use of PhET is a very positive one, because I noted that many of them were eager to interact with the PhET simulation. So the first time we introduced the PhET simulations, we were looking at the concepts of oscillation and waves, and students were captivated with the visualizations which were coming from the PhET. When we were discussing the element of amplitude, the students were able like to get what an amplitude is, just because they were able to see the amplitude rising on their screens. So the students have a positive attitude towards this, even though sometimes if we don't give them good guidance, they end up missing the concept. So as facilitators, we should always be on the forefront, making sure that the students shouldn't go astray. That is, the animations, they are very wide. So it's us who are using it. We have to design our lesson in a way that it should stay in line. The students shouldn't maybe go overboard. So my experience was that one, that they received it very well, as it helped maybe to it helped them with visualizations, good visualizations. And at least if we were, and after asking them to maybe give their feedback on what they have learned, they were able to give maybe diagrams which were close to what was being shown on their screen. So we noted that element of the visualizations was able to stick into their minds. So their attitude was a good one. I think there was another question which I did ask. You asked two questions, that one on the attitudes, then the other one was on what?
Yeah, how was the performance based on the study reviewed?
Okay, the performance in the studies which we reviewed, many of the studies showed that the performance was higher in terms of the statistical tests which they conducted. It was only, I think, 3 or 4 papers which showed no any change as in before the study and after the study, but many of the papers, they showed a positive impact on students' conceptual understanding, and that led us to further vote for the PhET simulations to enhance conceptual understanding. So the majority of the papers, which out of the 31 papers which we reviewed, 4 showed that there was no change as in performance, but the other ones, they showed a huge change. So we can testify that PhET simulations impacted the learning, as well as from the study which I further conducted on these PhET simulations. I say the performance was a good one. After maybe if we are to compare the performance of the control school and the experimental school where the PhET simulations were being used, I noted that the performance was a good one, and the teachers started adopting the use of the PhET simulations to teach in their an easy resource to use. So that's it on the performance of the students upon interacting with PhET simulations.
Okay, great. Thank you. Hello, Marianne. Marianne is asking, out of the 31 papers reviewed, were any based on research in Africa, and what education level were the participants in?
Okay. Yes, I had papers which were from in Africa. The review which I did, I had papers which were done in South Africa. So there was a paper which was done in South Africa on scaffolding learning. So papers were there which were from Africa, but many of them were from Europe. So this just shows us that us in Africa, indeed, we need to step up in the use of these PhET simulations in the use of in our teaching and learning.
Okay, great. Thanks. Herbert, you might not be aware, but your camera is currently on. So if just to let you know.
Okay,
I mean,
okay.
Turned it off, yes. Okay, so we have more questions coming in, and hopefully we can get to all of them. Tom is asking, Africa is a low-resourced environment for the use of PhET simulations, and the limits they are used to only whole class inquiry. What do you suggest as the best way to go about using the technology in such environments?
I didn't get the question. Can you come back again, please?
Okay, so he says there are limited resources in Africa to support the use of PhET sims, and this limits how we can explore use only to all class inquiry. do you have suggestions as to how to go about using the technology in a low resource environment? How do you use PhET in a low resource environment?
Okay. I'm lost as in I didn't get the question clearly. So I'm sorry to ask, please, can you come again?
Okay, yes, that's fine. I'll just read again. The person wants to know that because there are limited devices or computers in school, the way teachers and students can use PhET is impacted as a result to only all class inquiry. And Tom is asking, what are your thoughts, or how do we go about using technology? How do you go about using PhET in such scenarios where there's limited technology?
Usually when we have limited resources, the best way in which we are to use PhET simulation in that scenario is through demonstrations. So usually it is the facilitator who will use PhET simulation as a demonstration or as a tool for demonstration in that scenario. But in cases where the resources are there, then in case maybe there are few, let's say maybe 5 or 6 computers, then we can say we can use this method of group learning. But in case when the resources are very few, maybe just one, then the best way in which we can use that one is as a demonstration tool, where you're going to connect the simulation to a projector, and you use more like a lecture method. So use it as a demonstration tool. But if the resources in large amounts, then everyone needs to have it on their own, they manipulate it. And I don't know if it is now still in progress. I also noted earlier that PhET simulations have been introduced on phones. So that one, we can, if it is still on the Android app, the PhET Android app, if it is still on, then that can also be an option where schools can try maybe to purchase at least the mobile phones, which they'll be strictly being used for the classroom sessions, or they'll be used in classroom sessions or the lab sessions. Thank you.
Okay, great. Thanks again. I would just quickly add that you can also consider strategies while you're demonstrating, such as the predict, observe, explain, where students can work in group to make predictions and then maybe go break as in return to their cluster to make explanations. So there are different ways, but the bit is more, while the best case is to ensure every student, or the most effective way is to have students have devices in their hands where they can explore themselves. It's still a big step forward from the lecture method if you are just demonstrating. It means they have of course, there's the implicit scaffold built into PhET, or even from visualizing or seeing a lot of those things, all the abstract concept in visual, it's a significant step forward. While we continue to globally find ways to bridge the digital divide that's plaguing education generally across the world. Thank you, Paul. Paul said, I noticed that when you give teachers the opportunity to play with PhET sims, it helps to build their confidence. Yes, so it's also effective with students. So we always advise that you allow for a few minutes, maybe from between 2 to 5 minutes, for what we call open exploration, where students just try and figure out things, no clear instruction. They just try, this is how this object works. And that can also help curb their curiosity when it's time to work, because they most likely might be satisfied and they're not, you would manage their curiosity and they can focus on actual work when it's time to do the proper work. Vincent has a question. With virtual experiment approach, how do you balance this so as to avoid the traditional approach where students just follow instructions? I'll go over that again. Vincent is asking, with virtual experiment approach, how do you balance this so that students avoid the traditional approach where students just follow instruction? Do you understand the question?
Yes, I understood it partly. So I think I will answer it. Okay, just come repeat the question, please.
Okay, it's asking if you look at the using themes and the virtual approach, and of course the traditional approach in the lab, where students at times are meant to follow prescribed steps and then observe and get to an outcome. For simulations, students have open exploration. The rails are totally taken away or rather much wide. How do we ensure that students who perhaps have been conditioned with the traditional approach of following steps do not carry that attitude into a session perhaps with PhET or in a virtual teaching environment where they are just keen on following the steps as against exploring and then seeing the cause and effect of the act that they carry out?
Okay.
I think you answered the question earlier. I can speak to that quickly because I would love that we go through the questions. You answered on that earlier on around ensuring that teachers are there to provide rails or ensure that students do not get carried away. So it's virtual seems as amazing as they are, there's the likelihood that students can get carried away with the visual or just continue to explore and try to see the end or how far they can extend, how many resistors are in the seam, and they just keep dropping, even though you've told them drop 2 resistors and they want to see, oh, do the seams have up to 20? And they get to 20 and they keep adding and they're losing time on what should happen. So as teachers, of course, we need to ensure that we have that presence to guide. And of course, at the beginning, once they have that open exploration, which is why that is usually powerful, that can ensure that they've explored and they perhaps are satisfied, they most likely are satisfied enough to be able to do that. But there's that likelihood, so it's something we have to be conscious of and then provide the guidance to ensure that students are always at time. And as teachers, in this case, please do not stay in front. You need to basically move around the class to be able to support students, scaffold, basically support students when they need it. I hope we have enough time to go through the questions that we still have. We have a few more. I'll just run through it quickly. Yeah, you want to say something, Vince? Herbert, go ahead.
Yeah, okay. In our case, since we also use them in our sessions in physics laboratory, what we do is we have a manual where the guidelines are there. So what we do is we give them a room to explore it area so that they should know how they are going to do their manipulations. Then later, we give them time to focus on the task. So once they have achieved the required task, we go to each and every workstation or bench to check if it has been achieved the way we wanted. Once it has been achieved, we leave it to them to explore further, since in exploration, they tend to learn also more. So it's in that way that we give them time to focus on the task at hand. Then if time is there, we let it open so that they should enjoy the session through exploring more, as long as they are in line with what is being taught on that day. Thank you.
Okay, great. So thank you. We have 3 more questions that I think we must cover. Anonymous attendees asking, according to my research in teaching, I've been using PhET in Rwanda. I would like to ask the presenter, what is the pedagogical approach to adopt in order to raise student conceptual understanding? The speaker spoke about 4. Because of our time, we'll not be able to really go into the 4. I would advise that you just go back to the recording, which is going to be available on Facebook, on our YouTube channel, on the PhET YouTube channel in 24 hours. You can catch them up. He did recommend inquiry-based learning, project-based learning, exploration, experimentation with virtual lab, as well as scaffolding. But you can learn more. It provided clear steps to consider while adopting this approach. I must have answered the question, conceptual understanding, that's the same. How can we make the most of PhET in a typical African classroom, which is overcrowded with limited resources? I don't know, you've answered this. the initial question was more limited technology, but then how do you manage limited technology with an overcrowded class? Still, I think you've answered that around all class demonstration. Is there anything you want to say, or we should move to the next question?
Okay, that one, in an overcrowded classroom. So usually the best way is either the class can be splitted into half. At least the class can be splitted into maybe half, so that each and every maybe group should have experience of the virtual learning with PhET simulations. As well as another one is it depends on the numbers which we have. If sometimes I would say the groups also work, even though if the groups are too huge, it ends up maybe missing the objective. But the best scenario is the teacher has to sacrifice maybe some time so that the class can be split into half, maybe one group, so that into half or small groups, so that the session should be manageable. Thank you.
Okay, great. Thank you. I think we're 2 minutes before time. I also feel that we've answered some of the questions that are coming through. I'll just read through it, and if you can respond to them in 30 seconds, we'll be able to keep anyone beyond the hour mark, but I'll just get through it quickly. Damilare is asking, kudos to the PhET team for this information session. Thank you for joining as well. Could you please highlight more on how this effective and engaging simulation can be used beyond the classroom? I think I can respond to that. Then of course, you can use them in lots of ways. And my recommendation is visit the YouTube page, and you'll see multiple ways and scenarios that all of the amazing speakers from the past have recommended, as well as clear steps to consider when you are implementing it. There are no limits. It can be used in an array of contexts that you most likely would find fit. But most of the sessions have then provide specific guidelines to consider. So please, I would advise that you check the YouTube page out, or just get in touch with the team if you have further questions. And the last question we'll consider today is coming from Mwamba Utasi. I hope, again, sorry for pronouncing that wrong. Can PhET sim be a standalone teaching approach, or should be integrated into traditional teaching? So should PhET be a standalone teaching approach, or should be integrated into traditional teaching? In 30 seconds, and that will be our last question.
Okay, no, I would say it is important that we integrate it in the other teaching methods which we have. At least now and then we can introduce the sessions on PhET simulations in our classroom. It shouldn't be a standalone. Similarly, research also says on virtual labs, they say physical labs and the virtual labs, they work better. If you combine the physical lab and the virtual lab whereby you're using PhET, the outcomes are huge. As in, you can use the virtual lab for pre-lab, then the physical one, or the physical lab, is where they'll get to experiment with the physical apparatus. So if we can combine PhET with other teaching methods, the outcomes are better. Thank you.
Okay, thank you so much. We're on top of the hour, and we've come to the end of today's session of the Share and Discuss webinar. It's been a pleasure to have you all join us. Thanks to our speaker for his, of course, research, but also taking time to come share with us and answer questions we might have. We have to draw the curtain here today. Herbert, I don't know if you have a parting word, anything you'd like to tell the community before we call it a day.
I really enjoyed the session. The questions were amazing, and I would love if I can also do one more. Thank you.
Okay, great. Yes, we have. Hopefully, we'll get to that again. Thank you, everyone, for joining us. It's been a pleasure to spend the afternoon with you, and we look forward to having you same time next month, every third Wednesday of next month at the same time. Thank you, and bye for now. See you next month. Bye, everyone.
Bye.
Bye, Herbert.